Hello my dears. So today we are going to discuss about the concept of distribution system in power system. So I want to give you an overall view or what are the components in distribution system, and I want to introduce some terms: feeder, distribution and service. Normally there is a confusion among these three terms actually. So you might have a confusion between feeder and distributor, or you may not having an idea of what is mean by distribution or distributor, or what is mean by feeder. Okay, so that confusion also we are going to remove by the end of the session. Okay, so distribution system means, so we know that my dears, we know that the whole power system can be classified into three actually: generation, transmission and distribution. Okay, so now we are moving or more deals with what? Distribution side. We already discussed about the generation, we already discussed about transmission line and transmission system, and after that it is the consumer end side, right? Consumer side, that is called the distribution system. So this is the simple schematic diagram of a distribution network or distribution system. Why I have simply mentioned 132/66 kV from a substation? I mean, I started my distribution system from this substation 132/66 kV. Why? Because before that already it is 132 kV line is there, right? Because it is from the very far point, or it is from the generation side, right? We are generating the power at 11 kV. We have to step up to 132 kV and we have to transmit to a very long distance, because whenever the voltage increases, the current may be very low, so that the power's I square R loss will be very less. So that for transmitting power to a very long distance, normally we step up the voltage and by reducing the current, so that the power will be saved. So I am going to start my distribution network from this 132/66 kV. That means here it was 132 kV line. Okay, so from the substation side it is stepped down to 66 kV, and there is a transformer called and that transformer will be again step down the voltage to 66/33 kV. This 66/33 kV, this line is may be utilized for the primary distribution. Okay, if there are a very big cement factory or very big factories in near to this transmission line, then we can utilize the 33 kV for the industrial purpose. That is why it is called the primary distribution. Okay, 11 kV also sometimes useful for the primary distribution. Okay, generally 33 kV is used for the primary distribution. And after that again we are going to another transformer, that is 33/11 kV. That means it's again step down and it is again moved to 11 kV/440 volt transformer, and from that the secondary distribution starts. That means in our home and all now we receive power at a voltage of for three phase power we receive at a voltage of 440 volt. So that is the secondary distribution. So this is the distribution transformer. A one word question may be asked from this session as what will be the transformer, type of transformer, connection of transformer we are using in the distribution as a distribution transformer. It is in delta star format, because the transmission of power is very easy if you are using delta system, because it contains only three terminals. But if you require the concept of neutral, if you require a neutral wire, then the delta will not provide any neutral, so we are going for star. So in distribution side, right, in distribution side normally we are using delta to star transformation, I mean delta to star transformer. Here in primary distribution also, my dear, we are using a delta to star transformer, because here the industry also need a very big earth station, right? Very big earthing is required there also, so that also required a star connection. So whenever there is a utilization of energy, right, utilization of power, we required an earthing. So for that earthing, definitely we required a star connected system, no delta connected system. And of course, in the generation side also, the generator or the alternator, the stator winding of the alternator, simply the armature winding of the alternator is also connected in what? Star connection, because it requires a neutral. That's why. And the generation point also earthed, right? That earthing is actually make a continuity up to our home. Up to our home. Okay. Anyway, so this is all about the distribution. I mean a schematic diagram of the distribution. And we are going to focus on the term feeder. What is mean by feeder? It's a very important term in power system, feeder. Okay, it's a very important term in power system, feeder. So feeder is nothing but, my dear, it is a conductor which carrying power from one point to another, but there is no tapping in it. There is no tapping in it. That means, suppose a conductor, I will draw it here. Suppose a substation here, substation 1, and another substation here, substation 2. If power is transmitted from here to here, and there is no tappings, my dear, there is no tappings or there is no utilization of power. Tappings means definitely there will be a utilization of power, right? So from substation 1 to substation 2, or from generation station to another substation, if there is no utilization of power, only transmission, no tappings are taken from the conductor, then it is called a feeder. Then it's called a feeder. So this is feeder. That means in feeder the current will be constant. The current will be constant. The voltage might have been step up or step down by using a transformer, step up transformer or step down transformer, but there will not be any utilization of, there will not be any distribution of power, my dears. There will not be any distribution of power. Simply the transmission. That is called the feeder. So the feeder rating is determined by the feeder rating is determined by current. So feeder rating is determined by the current, because the current is constant. So that current, actually the feeder, the rating of the feeder is in ampere. The rating of the feeder is in ampere. This much ampere feeder, this much ampere feeder. That's okay. And next is distributor. Next is nothing but distributor. Distributor means nothing but, my dear, see the diagram. Here, this is a 33 bar 11 kV transformer. Suppose this is substation which is step down. The substation also contains transformer. This substation will step down the 33 to 11 kV, and suppose that 11 kV line now, it is continuously flowing to up to next substation, and no tappings are taken in between, then this is called 11 kV. I mean this 11 kV line now, its current rating will be something, right? Definitely it will be something. That is called the feeder. Normally we are saying 11 kV feeder, 11 kV feeder, but the rating of the feeder na, that 11 kV feeder, it is actually determined by the current rating actually. Feeder rating is always determined by its current rating. Its current rating. Okay. And see the next session. This is also 11 kV line na, but there is a distribution transformer which is connected in between or throughout the line. So many distribution transformer may be line. So this line is not considered to be a feeder. Did you get the difference? This line is not considered to be a feeder because it contains the tappings, my dears. It contains the tappings. Whenever it contains the tapping, the current rating is not same for all the session. The current here is not the current here. It's not the current here because tapping we already took. So that is the difference between feeder, okay, and the distributor. So these lines now, this is also another section. So this is the distribution transformer. This line now, this line is called distributor. Or this line, distributor. Or the whole line can also be considered to be distributor, because there are tappings. That's why it's called the distributor. Okay, and always remember one thing. It's a one-word question, mind. It's a very deep question actually. Distributor rating. The rating of the distributor is determined by its voltage rating. Rating of the distributor is determined by its voltage rating. Determined by voltage rating. Very important term, my dears. Very important. You have to note down. Feeder rating is always current rating. Distributor rating is always what? Voltage rating. And after that, so we completed feeder and distributor. And after that, see my dears, from the end of the distribution, distributor line, in front of our home, you may notice one pole now. That from that pole to your energy meter, there is a line, there is black cable, right? That black cable from the pole near to your home to the energy meter is called the service main. Okay, so this is nothing but, my dear, from the pole, there is actually a pole. You can say that here it's actually a pole, my dears. Okay, here is actually a pole. From the pole to our home, a black wire is drawn. That is called the service main. So did you get the difference of that various parts of distribution and difference between feeder and distribution? These two key points you have to always remember. Feeder rating is determined by its current rating, and distributor rating is determined by voltage rating. Feeder is current rating, distributor is voltage. Why? Because in distributor now, a 440 kV line means, even though it contains that line can supply thousands of homes, the voltage will be 440. Current may be different, but the voltage will be always 440. The current will be changed according to the absorbing capacity of load, means absorbing capacity of home. If a home contains simple 10 lamps and 3 fans, another home contain, or another house contain what? 2 AC and 4 inverters. Sorry, not 4 inverters. 3 ACs, 2 heaters, water heater now, that much load it contains. These two houses can be varied with its current rating, because house 1 absorb less current and house 2 absorb more current, but the voltage available to its energy meter terminal will be same, 440 same. So the distributor always contain, I mean the distributor line contains a constant voltage, but current is different. So distributor rating will be according to the voltage rating, and the feeder rating will be according to current rating, because feeder voltage may be changing, but the current is constant. The current is throughout the line, it is constant. So where you can see a feeder means in between two substations there will not be any, unless there will not be any tapping, unless there will not be any utilization of energy. There you can see the feeder. Where you can see the distributor, nearby your home, all are everything is distribution. From the substation near to our home to our pole, up to our pole, you can consider this all are distributors. No feeders is there. No feeder. Is it clear, my dears? So that's all about the distribution system. Okay, it's an overview actually. We don't want to move much deeper and deeper every session. We don't want that. We just want to know this much. Okay.